Without further ado, let's welcome Barrett. Go.
All right. Can you hear me okay? Are we good? Are we winning? Okay, welcome. Good morning. I am Barrett Clark. I've done Ruby for about a decade, and as you can tell, I am from the States. I currently work at the Container Store, retailer in North America. We specialize in organization and storage stuff, so we sell boxes, help you organize your closet, that kind of stuff. And yes, we have also started playing with containers, with Docker. There are lots of good databases, and Postgres is one of them. Today, I'm going to talk about a dozen tips and tricks to help you get the most out of your database and your application. So some of these tips are things that you can do in Ruby and in Rails, and some are going to be more database focused. I've got a lot of slides, so hang on to your butts. To start, let's see what's happening in the database, right? So for the first trick, we're going to see how Postgres wants to execute a query. So we have a query here that filters by a couple of fields. This 10K table is a table that Postgres developers use for developing their features and for running benchmarks. It's got 10,000 records, a bunch of different fields. You can see here's one of the records. That unique one field, there's also a unique two. There's 10,000 records, 10,000 unique values. The 100 field values from 0 to 99, 100 different possible values. Running a query plan in Postgres is as simple as putting explain analyze at the beginning of your query. And then when you execute it, you get this output instead of the actual results from your query. So it tells you what query you are analyzing and then the output. The default format here is text, but you can get it in JSON or probably other formats. If you really wanted to talk about XML, you could probably make it talk XML to you. Looking into the thing here, we can see we're going to do a sequence scan on the 10K table. We don't have any indexes, so naturally you would expect a table scan. Now, if you have a small table, indexes probably aren't really going to matter. You will probably table scan. That would probably be the most optimal way to get results out of a small table. But at 10,000 records, maybe we don't want to table scan that. If this is a query that we know that we're going to run often, or these fields are fields that we're going to use to filter regularly, then we're going to want to consider some indexes. And also as a rule of thumb, for foreign keys, you probably want to index those. Again, you're using those for lookups, for joining, for filtering. We add some indexes, we rerun the query, and we see here now we have a bitmap heap scan and a bitmap index scan. What is a heap scan? So that's basically a smarter table scan that takes indexes into consideration. So it only scans the records that it needs to instead of all the records, or more specifically, it scans the disk pages that it needs to. So it's more efficient. We add the indexes and we see here we've cut the execution time almost in half. Now, of course, every time you run the query, the execution time will be slightly different, and indexes won't always be this awesome, but in general, indexes are a good thing. Query plans can get pretty long. This one is a query looking at flight data. There's a bunch of subqueries, and it's a giant mess. I have no idea. I can see that it's taking 50 seconds to run, and in general, I would like to keep my queries faster than 500 millis. So this is a couple of order magnitudes worse than what I would really like. But what the hell's going on? Where are my hotspots? I don't know. So I can take the output from that explain analyze, that text output, put it into a visual query plan tool like this one, which has been around for quite a while. And at a glance, here I can see my hotspot is that filter by United Airlines. Now, there's a bunch of subqueries, so maybe that field is already indexed, maybe it's not, I don't know, but that would be where I would start. That'd be where I would start digging in. And maybe I need to add an index, maybe I need to partition the data, maybe I need to create a materialized view, I don't know. But that's where I need to start digging. We have other ways that we can visualize query plans. This one is a different website that is based on the tree view that pgadmin uses. I don't prefer this one because I can't as easily see the relative costs, because that's what I'm looking for, is where is my hotspot. But we have different ways that we can see query execution paths. But do note, different environments are different, right? The data the hardware and the configuration all play a role in how the query plan or how the query engine is going to execute a query. So that was proactive. Sometimes we need to see how things are running in real time. And for that, we have this thing called PG stat statements. In general, we can enable an extension in Postgres with this syntax, create extension. I don't know why it's called create extension, because the extension's already been created, but that's what makes it available in the database. Now, this assumes, of course, that that extension's already installed or one of the ones that ships with Postgres. And if you're wondering what is an extension, Postgres ships with 46 additional modules that aren't part of the core database functionality, but can be added into to extend the functionality. There are additional user-contributed modules that you can also install. And we would usually do this create extension thing in an ActiveRecord migration because those are a fantastic way to keep our databases in sync. But PG stat statements is a little bit different. It requires some shared memory, some special permissions. It's going to create a view and do some stuff. And so we need to edit the Postgres configuration file, which is postgresql.conf. That file will be in different places depending on what system you're on and how you installed Postgres. So you may need a little help also if you're using Postgres, the Postgres app on a Mac. And so fortunately, we have this show command in Postgres that can tell us where configuration parameters are. And so you want to look for the config file, or you can just do show all, and it'll tell you everything. The output looks a little bit something like this, and this is using a GUI tool called SQL Pro for Postgres that I kind of like. Open that file up. You're going to look for this line. Should be in there. Comments it out, but if it's not, you can just add it in. Save the file, and then you have to bounce to the Postgres server. You have to restart Postgres. And when you do, it will start logging statistics as queries execute. I mentioned it creates a view. PG stat statements is the name of the view, and that's where you can access the data that it's logging. So you can get things like how many total minutes has the query run, how many times does it run, what's the average execution time, and what even is the query. So this is handy if you need to see, like, suddenly everything's gone pear-shaped and you don't know why. This is a good tool for that. But it's going to do this on every query as it's going, and so you may notice a drag on the performance, and so this is not something that you would want to leave on in production all the time. Turn it on when you need to, turn it off when you're done. You have to restart Postgres server each time. And in general, the default setting is going to store the last 5,000 statistics. Rounding out our tools section, let's talk about how do we even access the database in Ruby. You don't have to use ActiveRecord or Rails to access the database. Here's some plain old Ruby that runs that PG stat statements query. There's a lot going on here, so let's break it down. First, we're going to load from a database YAML file, but they could be configuration. The configuration could be read from the environment or whatever. We just need how do we connect? What is the connection string? All that stuff. Read that in, feed that into PG Connect. We're using the PG gem, PG Connect. We've seen this query. I'm just wrapping it in a here doc and then pumping that into the connection.execute method or exec. And what we're going to get back from that is an array of PG result objects. ActiveRecord would take those PG result objects and do magic with them, but you're just going to get the raw data back, an array of PG results. Who here is familiar with this if file equal $0 pattern? Okay, a couple. This is a really handy thing. So this gives us the ability in that file to have classes that are available to other Ruby classes, accessible in IRB, accessible in Rails. But the contents of this block will execute if we run it from the command line. So when the file is required, this won't run, but if it's run from the command line, it will. So this gives us an executable script also. So we're going to run the PG stat statements, take the first 5 results, and print them out here. We can also use bundler in plain old Ruby scripts. It looks like this. So we'd have a gem file that would have that PG gem and any other gems that the project requires. We still need to require pretty print and YAML out of the standard library. So this is how we use bundler with plain old Ruby. Okay, next section, we're going to focus on a handful of data types to help make your applications easier to work in and more powerful. You can be non-relational in your relational database. Who here has ever worked with data from an API? Right, everybody. So did you create a local model that mirrors that remote resource that you don't control and probably is going to change? Or did you pick pieces out to store and then realize that maybe you'd thrown something on the floor that you needed? I like to store the entire payload. I may still pick out specific fields that I know that I need, but it's super easy to dig into that JSON or JSON binary field and get what you need. JSON binary is a more recent version, and it's stored in binary format, more easily indexable. So we can reference these data types in the migrations. JSONB is probably what you want to use. Using PSQL here, we can see some sample data. That payload field is just JSON. We do have a JSON pretty print function in Postgres, so you can see it formatted in a more nice way. We can run queries that pick elements out and filter by elements of the JSON field. So here, given the payload field, I'm picking out an ID and a name, and I'm filtering for a specific ID. We can index the JSON binary fields using a gen index. We can also index data inside the JSON field, which is pretty nice. We have a handful of range data types in Postgres. Today I'm going to focus on date range and timestamp range. So we don't have to juggle a start and an end date as separate fields. We can put them together in a single field as a range, which is super handy. You can still pick out and access individual elements of the range. So here I'm going to perform a calculation to calculate the duration of a flight so I can compare it against the actual elapsed time, which is a field in the data. And looking at the first three records, I see that only one of them actually lines up. So this is third-party data. Third-party data isn't always particularly clean. We also see here how the timestamp range is represented in the data. It's got that opening square bracket and end closed paren. Looks kind of weird, but that's how it works. Range data types have a bunch of weird-looking special operators that can help us dig into and quickly get the results that we need. And the gist index can make most of those operators faster. So here's an example using that flight data that looks to see all of the flights that contain a particular timestamp. So all the flights that were in the air at this particular point in time. That at greater than means contains. And so I can tell you, I don't know what time zone this was in, but at 4 in the morning on June 1, 1999, there were 81 flights in the air. Range data types are pretty sweet. For more on those, check out this talk that was at PG Open in 2012. Some good stuff in there. So the final data type is UUID. I've shown you a handful of data examples. You may have noticed that ID field is a UUID. You can configure your Rails app to use UUID as a primary key. To do that, we first have to enable an extension that generates UUIDs. Postgres core cannot do that. There are a couple of extensions, but UUID-OSSP is the preferred extension for that. We next need to tell our Rails app in the configuration file here, application.rb, that the migration generator needs to tell the migrations to set the primary key as a UUID, so that when we create our migrations, you can see there the ID is a UUID. And you can also see I've got a JSON binary field for a payload. One last thing to note, ActiveRecord's default sort is going to use the ID field. So if you say, awesome object.first, it's going to sort by ID and give you the first object. But UUIDs are not sequential. So we need to change the default scope to sort by a different field, which is sequential, like created at. In general, I like to store data as close to its native original format as possible. So putting a UUID in a UUID field feels pretty good for me. You do also get the built-in data integrity so that an invalid value won't store. If you somehow manage to mess it up, you just won't store the UUID, the non-UUID. And if you do use it for a primary key, you're guaranteed to not overflow your data type like you could with an integer. However, well, a knock on it is there are a lot of numbers in a regular serial ID, right? So it could be a premature optimization. And also, UUIDs for primary and foreign keys look kind of weird, and they're a pain to type. So your mileage may vary on that. The third section, we're going to move from data types to data. In fact, you can make your own data, which is pretty sweet. This is the trick that I'm perhaps the most excited about. So you can literally generate a series of numbers or timestamps, and while this may not seem all that exciting, it's pretty powerful. My favorite use case is generating a list of dates or date times for time series data, because you can't assume that all the points on the scale will be represented in the data, and so it's nice to have everything to fill in the gaps. Here's an example, again looking at that flight data, where I want to graph when an airplane was and was not in the air. This query is written in a style called common table expression, also known as a with query, where we have composable subqueries they're named subqueries that allow us to build up a complex query from really simple pieces. So let's break it down. We've got this first part where we're going to just generate a timestamp for every hour in 1999 using that generate series function. Our second subquery, flights, is going to get flight data for a specific airplane by tail number, and we're going to sort it by a flight timestamp range, which is the second field. That's what that order by 2 says. Being able to use positional field numbers for sorting is really handy. We don't have a calculated field in this query, but being able to sort by positional field numbers with a calculated field is really nice, because then you don't have to respecify the calculation. So finally, we're going to select from the results of that flight subquery. We're going to do a right join to bring in the hours, so we get all the hours, even at records that don't have corresponding flights. And so the flight data for those fields will be null. At greater than contains, we see this again, this is the line, this is the magic that joins the flights with the correct corresponding hour range. So the data looks like this. You see the null values where the airplane's not in the air, and this is the graph. I did this using D3. We can also use the coalesce function to help fill in missing data. So here we go back to that 10K table, and I'm going to count data on a field that has only even numbers, so I expect some holes. So I'll begin by generating a series from 1 to 10. Excuse me. And then I'll count the data in that evens field, expecting holes for the odd numbers. I'll fill those holes in with the coalesce function, which says pick the first non-null value from the list of parameters. So where we have a count, where there was a value even number, I have the count, otherwise it's 0. All right, this one may be a little controversial, but I love to give heretical talks. A view is a query that you store in the database, and it looks like a read-only table to your ORM, so ActiveRecord can see it. You can create a model for it. You can use it in your Rails app. And this is all well and good, but when would you want to use this? Maybe you're thinking. There we go. Do you ever have a query that you find yourself using repeatedly, maybe as a building block for other bigger queries, or maybe you use it to join in a handful of fields that you use for different purposes? So let's look at an example here. Let's say for whatever reason, we want all the records where that evens field has a 2, and we're going to do some pretty amazing reporting with it. And maybe this makes you a little bit uncomfortable because I'm suggesting that you put some business logic in the database. But I'm not saying put all of your business logic in the database. I'm saying that you are the boss of where your code runs, when and why and where. But there is also a way that we can give some control back to the Rails app, perhaps. Our friends at Thoughtbot, although Caleb's, I don't think at Thoughtbot anymore, came up with the SCENIC gem, which is a way that we can have generators to create models and migrations for views and materialized views. So we run the SCENIC models migration, and you can see we have model, we get unit tests, we get fixtures, and we get this new concept that introduces the idea of putting raw SQL in a file in this new folder, DB views. So we pull those queries, those giant walls of SQL, out of our models and out of our migration, and we put them in reasonable files that are versioned and easier to work with. If we needed to change this query for whatever reason, we would just have a twos_vo2, and rake db migrate, the SCENIC gem would say, oh, hey, I have a new version, so I need to replace that view. SCENIC gives us this create view helper in our migration. So we've got the SQL in the db views file, we run the migration, and boom, we have data. There's one other thing I should mention. By introducing database views, we've gone beyond what the regular schema dumper can express in Ruby, so we have to change that to output the schema in SQL. So again, we're going to update the application.rb file, and we'll now have a structure.sql file instead of a schema.rb file. So this may be a controversial idea, maybe it makes you uncomfortable, but I do like them for extracting complex queries and cleaning up gnarly joins. We can also create our own functions. And this gets really handy, because sometimes we need to ask hard questions of our data. Like, given a mortgage rate, show me all the records where somebody's house payment would be within some threshold or something. Well, we could plug this formula into the query, but that's going to be a bit rough. It'd be a lot nicer if we had the ability to just calculate that mortgage payment with a function. So here we have create or replace function, PMT. We're going to take in two parameters. Interest, which is a double precision, just a float. Principal, which is an integer. And we're going to return a numeric, which I believe is like the parent data type for double precision. So it's going to return a float. That $$ is just a quote in PLSQL. So then we have the contents of the actual calculation, end quote, and this is PLSQL, that language SQL. You can actually write like PL Ruby. I don't know that it's supported in the last 7 years or so, but you can write functions in other languages in Postgres. We can use an ActiveRecord migration to maintain our functions. Migrations are an awesome way to keep your database in sync. This is not a reversible migration, so we have to specify how do we create the function and how do we tear it down. So drop function payment, and we specify the call signature, because you could have a payment function that takes two parameters that are different. So that call signature is important. Now that we have the function, we can ask our database, hey, give me all the records where somebody's mortgage payment is over $100,000. We have some statistical functions in Postgres core, but median is not one of them. Why would you want to calculate a median? Well, maybe you need to calculate interquartile ranges, or maybe you just find median a useful statistical calculation. Don't worry about copying this down. It's on the Postgres wiki, and my slides will be available. This just says, given a set of records, or probably an array of numbers, array is a data type in Postgres, find the midpoint or find the average of the midpoint. So we can now calculate medians. Right, we've talked about a handful of tools to help with data. So now we're going to talk about tools to help expand what your database can do and what your database can access. Schemas allow you to safely have multiple databases in your database. Yo, dog, I heard you like databases. So think about it like this. On a server, on a physical host, you can have lots of things running, right? You can have multiple databases. In a database, you can have multiple schemas, and the schemas are where the tables, where the database objects actually live. Think of it another way. In rake tasks and in routes, we have the concept of namespaces to keep things organized. So in Postgres, we keep database objects organized, namespaced, by using schemas. The default schema is public. You can add more, and Rails can talk to them. Maybe you're thinking, wow, that's pretty cool. Why do I care about this? If I have a substantial ETL that's outside the typical process of an application, maybe I need to load some file and it's a one-time load, then I may load that into a separate ETL. Again, keeping the data as close to the original format as possible, and then apply my transformation into the actual table in the actual schema. So that ETL schema lives off to the side. It's just sort of a utility thing. It's not going to be part of the schema dump. Rails app doesn't really care about it. And then I can delete it or not. It doesn't really matter. We may also need to restore a backup and see what's in there, and maybe decide to merge in some old data or whatever. So to do that, we'd have to, well, the procedure is a little complicated. You have to rename the current schema because the schema is part of the restore. But then you can do your comparison and figure out where to move forward, how to move forward. And while this may be a bit of a fringe case, I have actually used it, and so it's a good thing to know that you have in your arsenal. Some extensions also create schemas to hold their functions. Remember, it's just a way to keep things organized, to keep things namespaced. So take, for example, PostGIS. We've touched on extensions now with pgstat statements and UUID OSSP, but PostGIS is my favorite extension. I love GIS. It's not one of the extensions that ships with Postgres, so you have to install it. And it has a bunch of dependencies you have to install also. You can use a package manager to install them, and you can also install them for source if you really want to. If you're on a Mac, you can use Postgres app, which includes the latest version of PostGIS. It doesn't require any additional setup. We can include PostGIS in a Rails app by including the ActiveRecord PostGIS adapter gem. And when we do that, we need to change the database adapter in the database YAML file to be PostGIS instead of PostgresQL. And we also want the Rails app to see the PostGIS schema, so we'll add the schema search path line. If we're adding PostGIS into an existing Rails app, we need to run this rake task, rake dbgis setup. And what that's going to do is enable the extension, copy in all the functions, and so you have the spatial functions and the spatial data types. If you start the Rails app out from the beginning with PostGIS configured, then when you do the db create, it'll do all that for you. It doesn't hurt to rerun it, but you don't need to. So now we have PostGIS, we can run spatial queries, so let's dig in a little more on that flight data. Well, it came with airline and airport data, so we can make sense of what the flights meant. So this is the migration for the airports data. And you can see I've got this st point data type that is a long lat, and it's geographic, and I'm also going to index it. One weird thing with GIS is you've probably learned, at least in the States, latitude, longitude, which is the wrong order as far as GIS is concerned. We talk about them in longitude, latitudes, usually, although some libraries still do it wrong. Here's the airport model configured for PostGIS. That module factories tells PostGIS what projection to use for spatial data. Aaron touched on projection earlier. It's really cool stuff, and we can talk about that later if you want to. I've added this before filter here, to before create filter, so that I can just create that point as new records are created so that I don't have to do anything special. The GIS stuff just happens for me. So that's what that factory's geopoint longitude latitude does. And I've mentioned I like to load my data as close to the original format as possible. Well, that includes bad field names. Long is a terrible field name for longitude, and lat is an acceptable abbreviation, but really we would just want to call it latitude and longitude. So I've added these additional methods so I can call them what I really want to call them. This is how, using the regular SQL spatial function, this is how we can calculate distance as the crow flies. This is from the San Francisco Airport SFO to LaGuardia in New York. ST distance sphere takes into account the curvature of the Earth and the position of the points on the Earth. We can also do that just in Rails using the PostGIS adapter. Under the covers, it's using a gem called RGeo. The calculation is slightly different. There are, I think, 3 ST distance variants. We can also ask more interesting questions like, well, what are the 3 closest airports to a point? If we're doing a flight search, this is exactly what we would want to do. You can see, for the most part, I'm using PostGIS directly. ActiveRecord PostGIS adapter has some nice sugar, but in general, I just drop down to the raw spatial functions. The documentation is pretty good also. So what we're doing here is calculating the distance. We're limiting it to the nearest 200 miles, or, 1609. So by default, we're going to use meters as the unit of measure here, because I don't want the nearest airport to be, on the other side of the country. That doesn't make any sense. You don't need PostGIS to do maps, but you do need PostGIS to do geospatial queries to support your map. My current mapping library of choice is Leaflet, provided by Mapbox. It's a JavaScript library. That's also outside the scope of this talk, but if you want to talk about GIS stuff and maps, then I would love to talk with you about that. Final tip here, foreign data wrapper. So you can access other databases and even other flavors of database from within Postgres. This may be helpful if you want to vet an idea like a data warehouse, or maybe you're splitting an application into smaller pieces, or maybe you're migrating from one database to another. And there are also wrappers for APIs, even MailChimp. I've been excited about this for a while, going back to an earlier implementation called DB-Link, and I've used it. But I have to confess, I'm not sure how excited I am about it now. I mean, it is great to be able to link to other databases and other platforms. And this has been available even on Heroku since Postgres 9.3. The current version of Postgres is 9.6. So we've had it readily available for a while. But I'm not sure how good of an idea it is really to design systems that require your databases to talk directly. Maybe if you need to ship data from one place to another, maybe that's a good idea, but I think your mileage may vary. And dependencies for cross-platform communication are particularly hard. I was trying to set up the Oracle foreign data wrapper recently, and I don't think it's designed to work on a Mac, and I just couldn't get it to work. It could also be that I'm just not that smart. I don't know. So consider instead having your Rails app connect to the different databases and let your Rails app, or whatever application you're using, be the one that brokers the data. Okay, since I panned that one, I feel like I should give you a bonus tip. I always enjoy seeing how people work and how we have our stuff set up. I have good news. You can customize your Postgres command line SQL experience using a .psql.rc file. This is mine. These settings only work when you're using PSQL on the command line. If you're using a GUI tool like pgadmin or SQL Pro or whatever, they're going to have their own configurations. So looking through here, you can set a prompt that tells you what server you're on. The timing will tell you how long the query took to execute. Autocomplete is nice. That history file, you can have a different history file for each database you connect to. And that /x auto is how I get output format that looks like this. So it'll either display the results in a table grid or one record at a time, depending on the fields in the data. And I did write a book, Data Visualization Toolkit. So if data visualization or geospatial stuff, there's a whole section on maps and GIS. If those are your thing, or you want them to be your thing, then come talk to me. And I have a couple of books that I brought with me to give out also. If you have any questions, then I would also, just in general, talk about data. I love data. I want to thank you all for having me here. This is my first time to be in Australia, and I've quite enjoyed it. So thank you.